All right, today we're going to look at the case number 6 of a minor arc above the interval. But I've got an example here of z minus 5 minus I. But you got to change that into arc of z minus z1, because at the moment it's not in the form of z minus z1. So you got to change it to z minus z1. And by doing that, so this is your z1, this is your z2. So where is Z1? 5i. 5i is here. So that's 5. That's I. Minus 7 I. Minus 7i is over here. So that's a bit off scale. Let me make it change it to scale. So that's better. So that's going to be 5 is like over here. I was a bit too far. So 5i is over there, and then 7 minus 7i is over there. So that's 1. So this theory says it's a minor arc above. So minor arc above means that it's going to be a minor arc, and it's above the interval. So that means that the rest of the arc is somewhere in here. Now that's a badly drawn circle, by the way. That, by the way, is going to be 2 pi on 3. So if you draw a line there straight across, this is nice and easy. So this is Z1, by the way. This is Z2. So if you draw a line nicely across there, and the center is somewhere going to be here. So which means then that this angle over here, oh, by the way, the other side of that quadrilateral, cycle quadrilateral is going to be pi on 3, because opposite angles are going to be added up to pi, which is 180 degrees, which means that this is 2 pi on 3, which means split in half will be pi on 3. So that means that this is, if I say this is A, C, and B here, and I draw that triangle over here for you to see better, so you can see. So that's a right angle triangle. That's your A, that's your B, that's your C, and this is pi on 3. This is that distance there from B to A is actually, I'll tell you, from -7 to 5 is 10 units. So halfway between that must be 5. So this must be 5. Let me call that the radius, which is BC here. Let me call that H. Use trigonometry. You can find out what the radius is by doing this. So 5 on R is going to be sine of pi on 3, which, by the way, is root 3 on 2. So it means R then is 10 on root 3. Using the same trigonometry, you got H, 5 over H rather. 5 over H is going to be 10 of pi on 3. So that means then that, look, I'm off the screen there. So let me go across there. So that means H then is equal to 5 on 10 pi on 3, which is 5 over root 3. So H is 5 over root 3 using the same triangle, and the radius is 10 on root 3. And you know the height here is 1, because it's 1 above the x-axis here. So that length there must be negative, this little length here. And that value is actually going to be 1 minus 5 on root 3. So that's that little height there from here to here. So that means that the center then is actually going to be at, well, halfway between there is 5 units. And so 5 units from the 5 here. No, it's 12 units. So I've gone berserk here. So that's 12 units rather, not 10. So this is actually going to be 6. So I was wrong. That's going to be 6. That's going to be 6 rather. So that's going to be 12. And that's going to be 6. 6 over root 3, by the way, is 2 root 3, by the way. So this is nice and easy, 2 root 3. So that's going to be, get rid of that. So the center, because that's 6 units, that's going to be actually minus 1. Okay, 6 units from 5 is minus 1. And the height of it is actually 1 minus 2 root 3. So that's where the center is. And the radius is 12 over root 3, which is actually going to be, well, 12 divided by root 3 is just going to be 4 times root 3 squared on root 3. So that's just going to be 4 root 3, basically. So that means the Cartesian equation you have there is basically this. It's going to be x plus 1 squared plus y minus 1 minus 2 root 3 squared is equal to that squared, which is 16 times 48. So that's basically the Cartesian equation of the locus of this minor arc that is above the interval, and that's where I'll stop.